Here we go. We didn't have a lot of time for this in class looking at the Module 11 example, so I'd like to do one here for you. We're going to do number 2, which if you read that question, we are asked to see, is this significant evidence that male and female drivers have different driving patterns? And you will notice there's 2 groups that were surveyed here, the males and females. So we're running a 2-sample test, and because it's significant evidence, that would be a hypothesis test. The 2-sample test, hopefully you got this formula from the online work. The formula is for 2 samples, when you're comparing 2 means, for a hypothesis test, you're calculating t is equal to x1 bar minus x2 bar, all divided by this strange looking square root that does have the standard deviation squared. And then one other thing to point out here, the online material suggests that you just calculate the degrees of freedom with a computer. However, you can get a good estimate by hand by just taking the smaller sample size from your 2 samples, take the smaller sample and calculate the degrees of freedom from that. And that's what we're going to do here. So we're doing a hypothesis test with 2 samples here. First step is to state the hypotheses. The alternative that we're asked to test here is whether we have significant evidence that male and females have different driving patterns. So that is, are their driving patterns not equal to each other? And that would lead us to the null hypothesis that the means are equal. Right away we can tell from the not equals that we are doing a 2-sided test. And we can go ahead and go on to step 2 here, which is to calculate the test statistic. And we can write down the formula is sample 1 mean minus sample 2 mean, all divided by the square root of sample 1's standard deviation squared divided by its size plus sample 2's standard deviation divided by its size. Remember, the degrees of freedom will be the smaller of the 2. And I'm just going to write down, put a place here to write down all of the information I need to get from the problem. The first sample mean we get is 12078. The standard deviation for that sample of females is 3423, and the sample size is 26. In my second sample of the males, there are 30 of them, having a sample mean of 13650 and a standard deviation of 2768. So the formula, when I plug that in for t, would look something like 12,078 minus 13,650, all divided by the square root of 3423 squared all over 26 plus 2768 squared all over 30. And you should go ahead and pause this video and perform that calculation. When you come back, here is my value. And the value I got was negative 1.87. And then the degrees of freedom, which I need for later on, if I look at the 2 samples, I just take the smaller of the 2. The smaller is 26. So the degrees of freedom would be 26 minus 1, or 25. So then in step 3, I go ahead and look for the p-value. And the p-value is going to be approximately, if I go to my handy table, looking at 25 and looking for, that was a 1.87. So looking at the row 25, 1.87 is right in between these 2 numbers. I go to the bottom. This was a 2-sided test, so my p-value is between 0.1 and 0.05. And I can go ahead and average those, or you may be able to do it in your head, and that works out to be a 0.075. Again, in this example, the significance level of alpha is not specified, so we default to 5% or 0.05. From that, we can compare the two. 0.075 is bigger than 0.05, and that leads me to conclude that we do not have significant evidence that they are different. There are several ways to state this outcome. The others could be we do not have significant evidence to reject the null, and many others. And that's all there is to it. For an example on confidence intervals with 2 samples, I'm going to put that on the exam review sheet, so you'll see that in a separate video.